In the next class, we will fully explore this implication of the relativity of simultaneity. So today, let's summarize what we have learned. We started by seeing that there was a conflict between Maxwell's equations and Galilean relativity. And then we saw that one way to resolve this conflict was to assume that there is a preferred rest frame called the ether, in which Maxwell's equations hold and the speed of light c is a constant in that reference frame and only in that reference frame. So there were attempts to search for the ether, and one particular attempt was this Michelson-Morley experiment. But this experiment resulted in a null result in that it could not find any sign of ether drift for the Earth. So this led Einstein to the idea of speculating that maybe the speed of light c is a constant, and it is a constant for all inertial observers. So we were led to Einstein's postulates for a new relativity principle, to reconcile the null result of the Michelson-Morley experiment to explain the null result of the Michelson-Morley experiment with our expectation of the law of Maxwell's equations. This necessarily means that if you are going to change the relativity principle, it means that Newton's laws, which obey the principle of Galilean relativity, must be wrong. And therefore, Einstein had to be very careful in picking out what the right postulates of nature were. And so we wrote down those postulates, and there were 4 very simple postulates of assuming that there are a set of inertial observers who are in a state of constant uniform motion with respect to each other, who all see the same form for the physical laws. Second, he assumed that one of those physical laws, or one principle of nature, was that the speed of light is the same for all inertial observers. And the third and fourth unstated assumptions or unstated postulates were the principle of homogeneity, that is, no preferred origin in space or time, and the principle of isotropy, which is that there's no preferred orientation for your axes when you try to describe the laws of nature. And finally, we saw that just by adopting these simple postulates, you find a very remarkable fact, which is that simultaneity is relative. That is, coincident events as seen by one inertial observer need not appear to be coincident as seen by a second observer who is in a state of uniform motion relative to the first one. This is a very, very deep observation, and it leads to a chain of thinking which will change our very notions of space and time. We will explore this more in the next class.